In this lesson, we will be discussing reaction types. After reviewing this video, you will be able to identify the 5 types of chemical reactions.
BOCABULARY.
Vocabulary.
Chemical reaction. The process by which atoms are rearranged to form new substances. For example, when you take lemons plus sugar plus water, that will give you lemonade. Yields, represented in a chemical reaction with an arrow. Synonyms for it would be forms, makes, creates. For example, using the previous example where we made lemonade, now lemons plus sugar plus water yields lemonade. The pink box will now outline the yield symbol. Reactants, the starting substance in the chemical reaction. Using the previous example with lemonade, the reactants would be on the left side of the equation, which are the lemons plus sugar plus water. Products, new compounds formed in a chemical reaction. Using the previous example where we made lemonade, this time the right side of the equation, or the lemonade, is our product. Anions, negatively charged ions. Another way of thinking of this is elements with negative oxidation numbers. For example, as you see in the pictures below, we have oxygen, which has an oxidation number of -2, and chlorine, which has an oxidation number of -1. Cations, positively charged ions. Another way of looking at this is elements with positive oxidation numbers. For example, looking at the pictures below, we have sodium, which has an oxidation of +1, and magnesium, which has an oxidation number of +2.
Did you know hydrogen peroxide is in a closed brown bottle? Because if it were in a clear bottle, sunlight would break it down into water and oxygen. This type of reaction will be discussed later in the video. Synthesis, when 2 or more reactants combine to yield one product. In our example, we will use Homer plus a donut, yielding Homer now with donuts. Summarizing this example, we have A plus B yielding AB. I would like you to note that we have 2 reactants, A plus B, yielding one product, AB. Decomposition, where one reactant breaks down to yield 2 products. Unlike synthesis, now we're starting where Homer has a donut and is broken down between a donut and Homer without a donut. To summarize this, we have compound AB yielding A plus B. Note that in this reaction, we have one reactant, AB, yielding 2 products, A plus B. Single replacement. In this reaction type, one element will switch places with an element in a reacting compound. An example of this would be Maggie Simpson standing by herself representing one element, reacting with Bart Simpson standing with his skateboard. Now in this case, Bart Simpson and his skateboard would represent a compound. As these 2 react, Maggie will steal Bart Simpson's skateboard becoming a new compound, and Bart Simpson will be left alone representing an element. To summarize this, we will have A plus BC yielding AC plus B. Double replacement. In this reaction type, two anions switch places with two reacting compounds to form two new products. A summary of this is as follows. Compound AB will react with compound CD to yield AD plus CB. A simplified version of this would be Homer wearing sunglasses representing compound 1. Homer would represent the cation, and the glasses would represent the anion. The other compound would be represented by Maggie and a donut. Maggie would represent our cation, and the donut would represent our anion. If we react these two compounds, take a couple of minutes to try to predict the products. I'll give you a hint. The cations are represented by Maggie and Homer, and the anions are represented by the donut and glasses. Now that you have taken a couple minutes, as you should have on your podcasts, the results that you would have gotten were that Homer now has a donut and Maggie now has sunglasses. To review this problem, we noticed that the donut and the glasses both represent the anions. Therefore, they would have both switched places. So now we have Homer representing a cation plus the donut representing the anion as one compound AD, and Maggie representing a cation, and the glasses representing the anion as another compound, CB. Combustion. This is a reaction that occurs when a carbon compound combines with oxygen, yielding carbon dioxide and water. In this slide, we give two examples. We give CH4, methane, and C12H22O11, which represents just another carbon compound, both reacting with oxygen, both yielding carbon dioxide and water. Now let's do some practice examples together. In the series of your studies, you may come across a problem that will ask you to identify the type of chemical reaction that has occurred. One example that we will do will be the reaction of sodium plus chlorine yielding sodium chloride. In this example, you will notice that two reactants yield one product. As you might have already figured out by now, this is a synthesis type reaction. Let's do one more practice problem together. In this practice problem, you will again have to identify the type of chemical reaction that has occurred. In this case, we have sodium hydroxide reacting with copper sulfate to yield sodium sulfate plus copper hydroxide. We begin this problem by identifying our cations and anions. In sodium hydroxide, we have sodium acting as our cation and hydroxide acting as our anion. In copper sulfate, we have copper acting as our cation and sulfate acting as our anion. As you will notice in our products, hydroxide, or OH, switch places with sulfate, SO4. As you have figured out by now, this is a double replacement reaction. As a closure for this lesson, you will have to identify the type of chemical reaction that occurred in these practice problems. This will be collected at the beginning of next class.